Welcome back. Chapter 3, Averages and Variation. So, note in chapter 1, we talked about planning a statistical study. So, planning basically. In chapter 2, we collected all the data and we displayed them, say, in histograms uh, or relative frequency histograms or pie charts and so on and so forth. So, display of data was in chapter 2. Now we are going to work with your quantitative data. So we want to figure out things like averages and variation. Section 3.1. First, measures of central tendency, mode, median, and mean. So what do these terms mean? First, let's look at the focus points of this particular section. Compute mean, median, and mode from raw data. Interpret what mean, median, and mode tell you. Explain how mean, median, and mode can be affected by extreme data values. What is trimmed mean? How do you compute it? And then compute a weighted average. Now, here is an example. Let's understand what these things are. The average price of an ounce of gold is $1,200. The Zippy car averages 39 miles per gallon on the highway. A survey showed the average shoe size for women is size 9. So you see, these are sentences, right? You have statements here. Average price, average so many miles per gallon, average shoe size. In each of the preceding statements, one number is used to describe the entire sample or population. Such a number is called an average. So with one number, you have some idea about the entire population. Okay, that's an average. There are many ways to compute averages, but we will study only 3 of the major ones. So, the easiest average to compute is the mode. So, you see, when we think of average, we always say, hey, add all the numbers and divide by total number. That's not what they mean when they say average. They want to understand what is called central tendency. In other words, you have given me a whole bunch of, say, for example, shoe sizes. I want to look for a central number which maybe is understandable for various contexts. What does that mean? If you give me a whole bunch of shoe sizes and I actually calculate the mean, that is, add them all up, divide by the total number. That is one way of thinking average. There are other ways of thinking of the central number, and that is mode or median. Okay, so one is the mode. The mode of a data set is the value that occurs most frequently. So you gave me a whole bunch of shoe sizes. I look for that shoe size which is most frequent. All right, that is the mode. For example, here are a bunch of numbers, right? Look at 5. How many times does 5 appear? Only once. Look at 3. 1, 2, 3. 3 times 3 appears. 7. Only once. 2. 1, 2. 2 times 2 appears. So far looks like 3 is the maximum, right? 3 appeared 3 times. Now 4. 1, 2, 3, 4, 5. So 4 appears more often than 3. So 4 has presently the highest frequency. 2 is done with 8. 8 appears only once. So which guy has the most frequency? 4. 4 is the mode because more words have 4 letters than any other number. So what were these numbers depicting? Counting the letters in each word of this sentence. So this is a sentence, and count the number of letters. That is 5 lettered, that's 3 lettered, that is 7 lettered, 2, and so on. That's how they got this set of numbers. And turns out 4 appears most frequently. So for larger data sets, it's usual to order or sort the data before scanning them. You see, this was a small list of numbers. We went through 5, okay, 3, and whatnot. But if you have a large number of numbers, then it's better to order them first before going through which numbers appears most. All right. Not every data set has a mode. For example, if Professor Fair gives equal numbers of A's, B's, C's, and D's and F, then there is no modal grade. So if you have two A's and two B's and two C's and two D's and two F's in your class, then every grade appeared twice. So there is no grade which appeared more often than any other grade. So there is no mode. So there is no modal grade. That means there is no mode. In addition, the mode is not very stable. All right. What does that mean? Changing just one number in a data set can change the mode dramatically. So for example, here you had two A's, two B's, two C's, two D's, and two F's. You had no mode. Suppose the professor gives three C's. Now suddenly C is the mode. Suppose the professor gives 4 D's. Now suddenly D is the mode. You understand? So mode is not very stable. Just changing one number or one grade can change the mode. However, the mode is a useful average when we want to know the most frequently occurring data value, such as the most frequently requested shoe size. That's correct. Why wouldn't you want to know? Suppose you are a shoe store. You want to make sure you stock your store with the most frequently requested shoe size, right? So mode is not very stable. Say 1 month number 9 got frequently requested, and some other month number 10, but still for you as a business it is more useful to have a mode. Okay, it doesn't make any sense to take averages of all the shoe size, average, that is add 2 plus 3 plus so on, and then get a shoe size of 3.5. Now who stocks something with 3.5, right? So you look for the mode. Next, another central tendency, when they say average they mean central tendency, that is useful is the median or the central value of an order distribution. When you are given the median, you know there are equal number of data values in the order distribution that are above it and below it. To find the median, the I hope the previous sentence was clear. What does median mean? You get a bunch of numbers, write them in order, that is smallest to largest. The middle number is the median. So how do you calculate the middle number? So order the data from smallest to largest. So you have a bunch of numbers, write them from smallest to biggest. If you have odd number of data values, say you have 11 number of numbers, then median is the precise middle data value. So there is a precise middle one. If you have 11 numbers, then 5 are on one side, 5 are on the other side, and there is one guy in the middle. Okay? But if you have 12 numbers, then there are 6 on one side and 6 on other side. There is nothing in between. So what do? You take the average of the middle two. Okay? So median is the sum of the middle two values over 2. All right? Let's see an example. So how many numbers are here? So what do barbecue flavored potato chips cost? According the prices per ounce in cents are given here. 19, 19, 27, 28, 18, 35. So look, this is not in order. So first step, order it. Place the 18 in the front and then it is in order. 18, 19, okay. So now how many numbers do you have? You have 6 numbers. 3 are here and 3 are here. Okay, so there is nothing in the middle. So you take the middle two numbers, add them up, divide by 2. Add them up, divide by 2. All right. So now, according to Consumer Reports, the brand with the lowest overall taste rating costs 35 cents. Eliminate that brand. Okay, so they are saying lowest overall taste rating costs 35 cents per ounce. So let's remove that number 35 and now let's look at the numbers. So you removed of the 35. Now here are the numbers. These are 5 in value. There are 2 here and there are 2 here. So the middle number is 19. So that is the median. So I hope it's clear. In the previous case, when you had 6, there is nothing in the middle. So you add these two, divide by 2. All right. But when you do have a middle number, that is your median. All right. So 1 ounce of potato chips is considered a small serving. Is it reasonable to budget about $10.45 to serve the barbecue flavored chips to 55 people? Well, you have 19 cents per small serving. This budget for chips assume that there are plenty of other foods. Okay, so that is your budget. 19 times 55, well, you're well within 1045. The median uses the position rather than the specific value of each data entry. If the extreme values of a data set change, the median does not change. This is why median is often used as the average for house prices. So for the house prices, you look at median typically. All right. So when you're looking for example, school district, they will look for median income. That way, you know, half the people are above that income, half the people are below that income. So if one mansion costing several $1 million sells in a community of a much lower priced homes, the median selling price for the houses would be affected very little, if at all. Okay. For small ordered data sets, we can easily scan the set to find the location of the median. But to find large data sets for n, you have a formula. Position of the middle. So you want to locate the middle value. You have n numbers, n plus 1 over 2. Okay. So if you have 99 numbers, 99 plus 1 over 2, that is the 50th number will give you the median. On the other hand, if you have 100, that is an even number of guys, that's 55.5. That is, there is no 50 and a half location. You have a location at 50 or a location at 51. So this tells me that the two middle values are 50th and 51st positions. So